All right. So I'm not sure if you'll be able to hear me. Let me just tilt my microphone. Or let me just move my microphone up. So yeah, this is the. I basically decided to do a video on the test because I saw that there were quite a few gaps in terms of like answering questions and the like. Maybe silly mistakes, as in maybe taking one value and confusing it with another. Then some of y'all will probably go as far as leaving a question blank. So, how do we fill the gap as a result? So, let's have a look here. I'm just going to expand my Adobe and then move on to just unpacking the test. Let's go. All right. So, I hope you will be able to see my screen right here. We'll be working on the test as stated earlier. Um, understand that my voice is low because right now it's 3:30 in the morning and family's asleep. So yeah, let's see here. And it's also a bit cold. Yeah, very chilly. Winter is here, buffet. So covariance, I think you should be able to calculate that by now. Sorry about that. You should be able to calculate that by now. Substitute your values from the formula sheet, and then you should get an answer of 10.268. Then you comment on the result. This result means that earnings and education move together in the same direction, and the covariance between education and earnings is positive, right? Then let's move on to B. Again, it's something that you should know. First things first, since there are no standard deviations in the given data, you're supposed to find them. You're supposed to calculate them. So that means you square root your variances to get your standard deviations. Then you comment on the result and say that there's a positive but weak correlation between education and earnings. So, notably, the direction of the covariance coefficient is preserved in the correlation coefficient. Cool. Then let's move on to C. I'm just moving as quickly as possible. You can like pause, rewind, fast forward, etc. Let's see right here. What's this all about? Okay, that's for C. So here you should have the formulation or the formula or correlation multiplied by standard deviation x divided by standard deviation y, if I'm not mistaken. But have a look at your formula sheet. Yeah, yeah. So there it is. There's the formula to find the slope coefficient, correlation times standard x divided by standard y. Then the alternative would be to calculate by using the following formula: covariance divided by the variance of x, and then you get the same answer. Then with the intercept, mean of y minus b1 times mean of x. And then moving on to the next question, whereby you interpret the slope coefficient, it's very important that you get your interpretation right, because not only are you just talking about the numbers, you should be able to explain economic theory by making use of data, and being an economist, you should know how to speak accordingly. So, in terms of interpretation, you say that a 1 unit or 1 year increase in education on average is associated with a 453 Rand increase in monthly earnings. So, notice how the slope coefficient does actually 0.453. You multiply that by 1,000 because um, earnings are measured in thousands of rands. So you multiply that by 1,000 to interpret it as an increase in monthly earnings. So it's 453 rands and not 0.453 rands. Very important. Then we move on to the variance of the error term. So you calculate it using this formula right here. So that funny looking, that sigma to the power of u2. You'll see this on your formula sheet as well. It represents RSS. So usually the variance of the error term is RSS divided by n minus k. So there's your RSS over there divided by n minus k. I think I also typed it there. So there you go. Maybe going a bit too fast, but this should make sense by now. And if you do have any questions, feel free to inbox me and then we can talk. Yeah. Then standard error of the slope coefficient. Let's see, it's defined by this formula where you take the variance of the error term and divide it by the deviation of x minus x bar squared. So just to show you what I'm talking about, I'm referring to this right here. Let me just show you. Yeah, I'm referring to this right here. So standard error of the slope coefficient is defined by this formula, and you should know what this means, right? Let's just move back to Adobe. I think you should be able to see the screen by now. So I hope that makes sense. You should have a standard error of 0,303. Yeah. Then let's move on to the confidence interval. You should know how the formula looks by now. I'll just show you again the confidence interval formula. Okay, for some reason it doesn't want to upload, but you should know how it looks. Yeah. But you should know how it looks. And this is the conclusion you should have reached. So you could just have a careful look at this comment right here on the bottom right corner. I'm just gonna pause for a moment, like I'll just let you have a look at this. All right. So you should just ensure that you follow the confidence interval step by step so that you can get every mark possible and ensure that your interpretation is right. Okay, moving right along. The sum of squares approach. Again, this is stuff you should know. And the interpretation as well. Notice how the error, not the error term, and the coefficient of determination is 0,089. But then when you're interpreting, you multiply it by 100 to get 8,9. And then you interpret accordingly as it is used to explain how the data is moving, how the data varies with one variable to another. Then we're going to move to question E, is it? Yeah. Question E, the F test. So using the coefficient of determination, basically you should know that formula as well, the ANOVA approach, where you have your r squared divided by k minus 1 over 1 minus r squared divided by n minus k. Yeah, so ANOVA approach, don't forget that. There's how you'd approach the f-obs, how you'd calculate the f-obs. And yeah, well, that's how you'd calculate it. But ideally, how would you start your question? This is how you'd start your question, by stating the null and alternative hypothesis. So in the F test, you are always looking at the overall significance of the model. But when you're testing for like the slope coefficient or the intercept, then you are using the t test. So I'm going to say it slowly. If you are testing for overall significance, F test. But if you are testing for the slope coefficient or the intercept, t test. I hope that is clear. So yeah, with the F test, we often find that our null and alternative hypotheses don't always end up being like your B1 equals 0. Like sometimes you can state it as in numbers, but then it would be very nice for you to state it in words as well. So here we have our null hypothesis, which states that the fit of the intercept only model and the estimated model are equal. And then the alternative hypothesis states that the fit of the intercept only model is significantly reduced compared to the estimated model, right? Then the decision rule states that if f-obs is bigger than f-crit, you reject the null hypothesis. And then if f-obs is smaller than f-critical, you fail to reject the null hypothesis. So failing to reject does not mean you're accepting. You are simply failing to reject. Like, for example, if you're in a court case, you may get away with murder, but there are like other chats to that. I don't want to get into that now. So you state your null, you state your alternative, then you're going to calculate your f-obs, which you should follow in the method that I mentioned earlier. And then you compare that with your F critical that you should find on your F table. And I noticed that n minus k equals 23. And I think in the F table, you have 22 and 24, you don't have a 23. In such cases, if you're in the middle, you go with the bigger value. You always go with the bigger value. But in this case, 7.95 or even 7.82 is acceptable. They're not exactly far off from each other. And then you come to your conclusion where you state that you fail to reject the null hypothesis because the F crit is bigger than F obs, or F obs is smaller than F crit. You state that you are failing to reject the null hypothesis, and you therefore conclude that the estimated model is not better than a model with no explanatory variables. Right. Then moving on to the predicting of average earnings for an employee that has 16 years of education. So you make use of this formula, right? You make use of your regression model. Very important. That's why it exists. You are substituting X basically. So you have your regression model, which is 2,831 plus 0,453x. You just replace x with 16, then you should get an answer of 10,08. But remember, we are talking about earnings which are in thousands. So the answer doesn't stop there. You multiply that answer by 1,000, and then you say that the average earnings for an employee that has 16 years of education stands at 10,080 Rand per month. Yeah, I hope this one made sense. Then the last question for question one, or the last sub question or question under question one, yeah, is as follows. It's the Jarque-Bera test. I hope you managed to understand this. You state your null, you state your alternative, and it is as follows. Your null hypothesis states that residuals are normally distributed, and then your alternative hypothesis states that residuals are not normally distributed. How would you know? Simple. This is how this is how you would know. Basically, if your residuals are normally distributed, you state that your null hypothesis is as follows: skewness is equal to 0. You don't have to write this down, but you have to know. You just have to know this. Skewness is equal to 0, and then kurtosis is equal to 3. And then that would be the opposite if residuals are not normally distributed. And then you just need to know another thing as well, that for the chi-squared table, so this right here is chi-squared. That variable over there is called chi-squared. Your degrees of freedom will always be 2. Your alpha will be 5, unless stated otherwise. If it's not stated, it's 5%. But then in this case, it was stated that it's 5%. So just watch out for that. If you are told, do the Jarque-Bera test, and they don't tell you what the percentage or the level of significance is, by default, it's 5%. But if they say it's 1 or 10%, then you follow that. So yeah, in this case, we have a decision rule as well that we need to follow. If JB, which stands for Jarque-Bera, is bigger than chi-squared, then you reject the null hypothesis. Then if JB is smaller than chi-squared, you fail to reject the null hypothesis. And then there's a formula for this, for JB specifically. I'm just gonna pause sharing my screen rather, and have it here. Just gonna share it in a moment. Yeah, so this is what the formula is for JB. You have N, which refers to your number of observations, in this case 25. Then you have your skewness and you have your kurtosis. I'll repeat: number of observations, skewness, kurtosis. I hope you know what to do here. Just substitute the values, then you compare and do the rest. Cool. Now I'm just going to go back to sharing my Adobe screen. So after following those instructions, you should get the following. You should get a JB statistic of 2,12, and then the critical value is 5,99. So because the JB test statistic is less than the critical value from the chi-squared table, we fail to reject the null hypothesis, and we can therefore conclude that the residuals from our estimated regression are normally distributed. Now let's go to the last question, which speaks about the assumptions of the classical linear regression model, and this being blue, BLU. And then you just need to speak about best, linear, and unbiased. I also feel like it's really interesting to know different theories by making use of mnemonics. And what a mnemonic is basically um, spelling out something to make sure that you remember it. So BLU, blue, you remember that it's best, linear, unbiased. So in the comments, I wrote down that best refers to minimum variance, and you just need to elaborate on that to get your marks. And then linear model, you state that a model is linear when each term is either a constant or the product of a parameter and a predictive variable. Then you need to discuss the concept linear in parameters. And there you are discussing the relationship between the two variables, what is defined by linear in parameters. And you just really familiarize yourself with the textbook, like just get to understand what these concepts mean. Then the last one is unbiased or unbiasedness. Well, basically unbiased, and you refer to unbiasedness. So in the event that you are speaking of um, what is unbiased, you are specifying that the expected value of an estimator equals the parameter that is estimating. Then you go on to define unbiasedness, and then there you'll get your marks. You can't get marks if you're just stating best, linear, unbiased. You need to elaborate. Basically, what you need to do is just explain these concepts in a way, like pretend as if the lecturers who are teaching you, the tutors who are facilitating your progress, know nothing of these concepts. So even when you interpreting your covariance and your correlation, you need to think about those things. Yeah, I think that's the end of the video. Looking forward to hearing more from you, and stay winning, most definitely. We all gotta win. We all gotta make sure that if the result is good or bad, we just keep the fire burning. We remain persistent, consistent, and just make use of your resources. Right now, I heard that there's a class rep. I hope that you're speaking to the class rep. I hope you're also sending emails to your lecturers. Then you have us, your tutors, who are here to assist wherever we can. And most definitely, I keep on saying this: just keep on work with your colleagues, work with your colleagues. Um, Even in the face of struggle, or if you are thriving as well, just really do what you can to make sure that you get the best out of this course. I hope this helped. Thank you.